So over this video, we will build a RAG-based chatbot like this that runs completely locally without any OpenAI API key or Gemini API key. So it's going to be using Llama 2 to run this locally, and we will be building this on top of RAG, which is a framework that is used to enable machine learning models to get data beyond their training data set. You'll learn everything you need to know, but for now, let me show you a demo. So once I put the prompt in here, this is the document this is basically a print screen of OpenAI's web page. So I printed this and I'm telling my model to summarize this, and you can see it's able to summarize the information like this. And when you put in a follow prompt, so let's say write a blog on this, then it's going to wait some time and use local model, not OpenAI API or not Gemini, to write the content for you. So this is built on top of Streamlit Python code-wise, and it utilizes Llama 2 to generate responses for you. We will use LangChain in order to do the processing, the process of getting the data and pre-processing the data. So let's get started now. First, let's quickly understand what RAG is. Again, I found this in the first result, so I'm just going to read this. Or we can also use Perplexity. So this is what exactly RAG is, and if you've been in AI in any capacity, you know that this is a technical concept that you want to study, but you weren't able to study for one reason or the other. So let's just quickly go through the concept and then dive into the architecture of RAG, and then finally dive into the code of RAG in order to build this. So RAG is referred to as retrieval augmented generation. It's an advanced technique that is built in order to address some of the limitations of LLMs, which basically means outdated knowledge. So let's say a good example here would be, if a model was trained for the data on 2015 and you ask it a question like, is Pluto still a planet? Then the model is going to say, yes, it's a planet, because before that date, Pluto was planet according to the sources that were available. But in reality, it's not. So the data that the model has is outdated, or it will have hallucinations, which means it will generate fabricated information. And you will not also know where the data is coming from, right? So if it's able to generate the output for you, end of the day, you don't know where the data is coming from. So in order to address problems like these, the framework called RAG was built, where you would connect the large language models to a vector database or the source directly. So let's say if I want to know today what is the source of, or if Pluto is still a planet, if I connect my data set to something like NASA's website, then in real time, I will be able to get the response with respect to whatever astronomy questions I have, or whatever details or questions that I need from the website itself, without getting outdated knowledge, without getting hallucination or non-transparent reasoning process. Now, this is just a basic example. RAG can connect to a bunch of different sources to get you information in real time. And the best example of RAG that you're looking at right now is Perplexity, right? You can see it's because the model is only limited with respect to what these concepts are. So model will probably not know about RAG if it was trained before, say, 2016 when RAG was popular. But Perplexity kind of looks through a bunch of different sources, and then it also gives you the list of sources that it looks through before it answers the question for you. So Perplexity is a great example of RAG, where it's going to look through various sources, send it to the model, and then process the data for you. So how does RAG work? How does the architecture of RAG looks like? Let me quickly get that to you in a second. So this is a very good example of a RAG architecture. The user puts a prompt to a web app or the RAG application that you're using. So in our scenario, Perplexity. So let's say you type something on Perplexity. What Perplexity does is that it goes to its retrieval system. Now, retrieval system is connected to a document repository, or it's connected to a web search engine like Serpert that will look up data in real time. But effectively, what this retrieval system would do is that it has processes to access the docs that the user wants to access. So let's say if I'm searching about space, it's going to only look at those searches that are relevant from the space standpoint of things, right? If I search space on Perplexity, it's going to use a search API like a Serpert API, and then going to look at all the top results that come after we look for space. It's going to look through each of those results, extract text from those results. So it's going to do semantic search, relevant documents, and then give us the output. So again, before we get to the output, what happens after it gets the text is that it sends the entire text to an LLM. like let's say GPT 3.5, GPT 4, or Claude 3, and so on and so forth. So you have different options that you can select from. Now the LLM has the information that it needs, the most updated information that it needs, and then it would also send in the user prompt. So let's say the user prompt was to write a blog on RAG. Now it looked through all the top search results for RAG, got their text and the user prompt, feed it to LLM, and then LLM generates the response for those details, which is then sent to the web app and hence the user. So effectively, this is how RAG works, is that you have something called a repository. Now this is also called VectorDB. Now let's say if we remove the perplexity's complexity of say search API, because that makes it simpler. You will just search through the top documents and get the data. But let's say we don't have access to search, then how do you get information? Right? So effectively what happens in scenarios like those is that you set up a VectorDB and you set up embeddings. Embeddings are basically numerical representations of a probability of how likely is this document referred to the prompt of the user, right? So it's a probability. If it's high probability, then what retrieval system will do is it will fetch that document because it has the higher probability of that being a user's document. And all of these documents are stored in smaller chunks in these vector DBs, which is something also we'll build through the application itself. So once it fetches this, again, it sends to LLM, and then LLM generates the response, and then it's sent to the user. And it has a bunch of different use cases, right? So one of the popular use cases is customer support chatbot, where you would build a RAG-based application to answer the questions for the users in real time. So let's say you have a product that primarily builds API-based documentation and lets your users use API. Now, because your API documentation changes day by day, it's very hard for the user to keep up to date with the documentation itself. So what you would typically do is you would connect system directly with your documentation, such that every time a user is asking the question, the RAG system would look inside of the repository. If the question is not available inside of repository, then it's going to look through external docs as well. So this is another architecture that does exactly this, right? So it's going to look through all of these sources. So either it's a doc, document loaders, classifiers, embedding, chunking. It's going to do a bunch of different things before it's going to generate the response. And all of this is also stored in VectorDB so that in the future, when the user is asking or looking for that same question, then it's going to generate the response in real time. And it's not going to look through the document then, unless there has been some changes in the documentation. So you also need a way in which the document is updated in real time. Another most popular example of a RAG is ChatGPT, right? Now, why is this a popular example of RAG? Is because when you go to explore GPTs, and these are actually what RAG-based applications are, right? So let's say there is a website that generates code. If I type things like Next.js, right, which is a programming language, and you can see this is a Next.js expert that can write code for Next.js. Now, the reason why you need a separate custom chatbot for this is because current ChatGPT is not able to answer questions based on Next.js 14 because it's new. So someone created a RAG chatbot that is looking at the documentation of Next.js and answering questions in real time. When you go inside of Create GPT and you go inside of Configuration, you have a couple of options: the knowledge base and the action. Knowledge base is again where you upload a bunch of PDF documents or Excel documents and so on that will be used by the model before it answers the question. But you can also create an action where you can fetch all of this information in real time. So if you click on action and you look at the examples here, you can see this is the weather JSON, which will effectively fetch the weather location in real time. So if you test this, it should be able to fetch these details. You can see call the weather example.com API and get the current weather. So it's now fetching the weather in real time and post that, giving you the output. Weather is a great example primarily because this keeps on changing every day. So you can see there was an issue primarily because this is just a sample here. But anyways, I hope you get the point. So there are two ways you can connect your RAG, or maybe three ways. First is you can connect with your actual documentation and look for updates. Second one would be to upload the documentation, but it will not look for updates. Third one would be doing something like Perplexity search, where you look for everything in real time, or custom actions that we just saw on the ChatGPT interface here. Again, so you know what is RAG, you know how it works. let's take a look at some of the use cases of RAG. One of the popular use cases of RAG would be, like I said, customer support chatbot. Second would be in scenarios where you are doing employee onboarding, right? So let's say you are onboarding newer employees and these employees are asking same question again and again. Then that's another good use case of RAG, where you can set up an employee onboarding chatbot which your HR team can circulate, so that the same questions don't get repeated again and again on their side and help make their lives easier. So again, anywhere where your data is updated in real time, so let's say stocks, if someone is doing financial research, and because the data of companies keep on changing, a real-time RAG chatbot that can give you most updated information about the stocks and financial information would be an ideal use case here as well. Let me know what other use cases that you guys can think of. The funny part is that the roots of the RAG date back to 1970s with the development of question answering systems. So very interesting. It's not a new concept, but it has now found application post the emergence of AI. And the reason is simple, right? So generative AI today is not proper AI. So it's not doing regressions. I mean, it's doing regression, but it's primarily good at generating newer content. So if you go to Sora and you look at their recent blog on the newer updated videos, so if you go to blog and you look at first impressions, you will see that Sora is most powerful when you're not replicating the old, but bringing new to life and impossible ideas we would otherwise never had the opportunity to see. So this is true for all the Gen AI models, where they are good at generating newer things rather than replicating the old things. And the reason is simple, right? When you look at a video, let's say this video, and you can see this generation, you've not seen this before. So for you, this is new, and for you, this is interesting. You have no other parameter to judge this image on. So naturally, you will think this is a great generation. But if you were to tell it to generate an image of an actual giraffe, then you're not going to be that impressed, because that's something that you've already seen, right? So generative AI models are good at generating things, but they are not great at analyzing things, in general, doing regressions and sorts. When you tell it to do regression, yes, it will do regression, but it's going to write the code in Python to do regression. It's not going to run regression on its own capability, because its job is to process and generate text, not run regressions. And why would we consider using RAG, right? So the point is simple. If you were to train a model for your use case, so let's say if you were to build a model that can look at your documentation and answer the question, now let's say you trained it on your documentation, right? And tomorrow your documentation changes again. So you'll have to do retraining again. Plus you are now training the model on the old data and the new data. So again, when the output is reaching to the end model, it now has two pieces of information. The model does not know which one to trust, and it's likely that it will either hallucinate or give the wrong answer, which is why it's ideal to not fine-tune a model. And if you don't know what fine-tuning is, it's effectively ways in which you can train a model to answer specific questions. So for example, if there is a model that detects images or faces, and you want to build a model that can detect, say, books, or which books is the user looking at, then in those scenarios, you would typically train a model on a bunch of book images and label book images with respect to which books those are. And then, expect the model to then figure out what the book is in the front that it's looking at. So again, it's ideal for those use cases, because books are not going to change, or covers are not going to change as frequently as your documentation. So for those scenarios, you would typically use RAG and not fine-tuning. Going the fine-tuning approach would also be expensive, because you're going to use GPU power, TPU power for training processes, and then there's going to be a team who's going to be doing that training. It all becomes too complicated. So rather, better off using RAG for those scenarios. So again, I guess you have some high-level understanding with respect to what RAG is, how it works, and why we use it. There are certain disadvantages, of course, that it's a very simplistic framework, and it's possible that it does not give all the information that the model needs to answer the question correctly. So ideally, for example, if I showed you the chatbot here, right? Now it's giving me the answer. But if I ask very specific question with respect to, let's say, what is Sora, then it's not going to give me all the details I need, but also some extra information with respect to the model, which is something that I'm not, say, looking at this point of time, right? Plus, sometimes because it does not have all the information, the output it generates may also be incomplete. And plus, in scenarios where you don't have that documented, it's going to just say that, hey, I don't know the answer for it. While it's good, it's still not going to, completely give the answer that the user was looking for. So in those scenarios also, RAG is not very helpful. And hence, having all the documentation in place or ensuring that you update documentation in real time are all the solutions that you should be looking at. But in this scenario, we're going to be building a very simple chatbot like you saw here, and we're not going to over-engineer it. I'm going to walk you through everything you need in order to build this, all these systems, things you need to get this working in your local computer. So again, like I said, we'll be using Llama 2 specifically to run this. So we are not using any other API. Are there any other things that I need to cover on RAG? Again, this is not a deployment-based chatbot. This is just a local chatbot for you to learn what is RAG and how to build it. So I think I covered everything with respect to what we need to know with RAG. Oh, by the way, I didn't mention this. So RAG is basically retrieving something, augmenting it, and then generating the response based on the augmenting meaning making the response better, right? So this is effectively what RAG is. Getting extra information, making it fancier, and then generating output based on that extra information. So again, this is a great solution. I'm not sure who invented it, but it's solving the problem really, really well. And if you don't know what LangChain is, it's a popular library or a framework in order to build a LangChain-based or RAG-based application. So it has extensive documentation and community as well. Let me look up LangChain, and you can see the website here, and it is open source, right? And allows you to also build agents apparently, which is something that we should probably cover in future. But yes, it has a huge community of people building apps on top of, and there are certain things that you would do in real time, right? So let's say for now, we're just looking at PDF-based chat. Let's say if the user wants to chat to a website, now typically you would write the entire code to say, go to that website, extract text from that website, clean that text, and then process it. But because we have LangChain-based systems in place, all of these things become easier, right? So you can directly use their libraries to do all of this real time. So instead of writing all the code, you can just say, go to this website and get the data. And it will, in the backend, it has all the code that is necessary to do all of that processing. So again, it's a great resource that way, and a huge community of people building on top of this. So they have comprehensive docs as well. In scenarios where, let's say you find this interesting and you want to build on top of this, then you can also explore this. I wanted to build LangChain-based video for a long time now. So I'm glad I'm finally kind of working on or building this now. So let's get now started developing our LangChain-based chatbot. And let me just, let's just go through everything we need first and then start building it. So let's start now building the chatbot from scratch. So the first thing you will need is the Python framework. So go ahead and download Python from here. The reason why we'll download this is because in order to run Python code, you will need the Python framework in place. So it's, again, if you don't know what Python is, it's a programming language that is popular for machine learning based use cases, and exactly why we are using it for chatbot. Now, the other thing that you need to know about Python is that it's backend based language. So it does not have a front end. So if I go to any website, let's say ollie.social here, this is a website built on something else and not Python. So the website front end is built on, say, Node.js, while whatever happens in the backend may be powered by Python. And hence, that's exactly why it's called the backend language, because it does not typically have a front end. But then there are tools or libraries like Streamlit that enable Python to also have the front end. And I'll also explain what are libraries. Second, you need Visual Studio Code, which is effectively where you will write Python code. So go to Visual Studio, code.visualstudio.com, and download whichever operating system you have in place. Third thing you need is the Ollama framework. Now, just like Python enables you to run Python-based code, Ollama is a simple framework that allows you to run machine learning models, open source machine learning models locally. So if you go to the download page, you will be able to find downloads for a bunch of different OSs here. The Windows one was in the preview. It's still in preview, but you can download it if you want to. And then when you click on models, you will have a couple of different options. There is Llama, Mistral, all of these popular open source models. Now, I believe Mistral is more accurate than Llama 2, but because I have Llama 2 downloaded in my computer locally right now, I'm going to be using that. So again, in order to download any model, once you install Ollama, you can see it should appear here. in if you're on Mac and in somewhere if you're on Windows. But once you have this running, you will be able to see something like this, which means it's running successfully. Now, when you open terminal, in my scenario, it's terminal, but in your scenario, it can also be CMD if you're using Windows. You can do Olama run llama 2. Or you can look at this command here, right? It's basically just this. If you copy this and paste it here, then you are now running local Llama chatbot in your computer. Note that for running Mistral, there is a different command. So if I were to run Mistral, I would do Olama run Mistral, in which scenario it would first install the model, which is around 4.7 GB. So before you even install this, you can see it's 4.1 GB here. You will need to download it first. So ensure that it's downloaded locally and then you can use it. So if I do hi now, and you can see I'm actually chatting with the Llama 2 chatbot without paying for it, right? So I'm basically running an open source model locally. Llama 2 is not that great. Mistral is great, but because I have this, I'm going to go ahead with this. You can download Mistral if you want. If in order to stop this chat, just do buy. Again, it's not completely free. Obviously, it's taking resources from your laptop in order to run it, but it gets the job done. So once you have downloaded all of the 3 things that I mentioned here and started the download for Olama Run Llama 2, you don't need to wait for it to complete because we will do other steps in the meantime. Now let's set up the project, right? I'm going to be also documenting the steps here. Set up the project. And for this, we will open Visual Studio Code. So go ahead and now open Visual Studio Code and you should be able to see something like this. Once you open this, you need to now open a folder where you will write all your code. Right? So click on open here, do YouTube rag. In my scenario, I'm going to put YouTube rag and then click on open. And you can see a new folder is created. So your project is basically set up, right? So basically go ahead and create a folder and inside that open that folder where you will write the project. Next thing you need to do is open the terminal. So terminal is effectively where you will run all your code and command the code to run, right? Or if you want to download something and then you can do all of that here. It's similar to this, just that it's specific for this project because you can see it's inside of this project, right? So it's a terminal that is for this project. Okay, next we need to set up a virtual environment. Now, what is virtual environment, right? So virtual environment is basically an environment that is created for this project. You saw that we will install these 3 things, right? Now we don't want it to install across our laptop because I just want to use it for this project and I want to remove it once I've used it. So in order to avoid installing these things across my laptop or project, I'm going to just install it inside of this YouTube rag project so that I don't end up getting in problems when I want to remove it from my computer. So just set up a new virtual environment here and I'm going to be showing you the command that you need to run. So go ahead and terminal and type Python 3.11 depending on whatever version of Python you're running and do -m and venv, which basically says Python 3.11 make virtual environment called rag environment. So this should create a folder here and you can see it was able to create a rag based environment. Now we need to activate it. You can see it's currently still in the terminal based, meaning it will install it in your entire computer. So we need to specifically mention that whatever I run now needs to be inside of this. And for that, we need to activate this. So we'll type source and then the name of the environment, rag environment /bin. So we are going inside the bin folder of this and then typing activate. This should activate the rag environment. So now we are inside of rag environment and whatever we do will be just inside of this and not across a PC. So your basic setup is done now and you don't need to do anything else. We can start writing the code. So in order to write your first piece of code, create an application.py or app.py. This is where you will write all your code and you will use this terminal to run your code. So while I did mention we need a couple of libraries like LangChain, Streamlit, OS and Time, LangChain is basically, like I mentioned, we will use this framework. We went to the LangChain website earlier. So we will use LangChain from here to use their own pre-built frameworks. For example, if you want to split text into smaller chunks because you can't in bulk do that. So all of those libraries and all of those methods, functions are available here. If we weren't to use LangChain, we will probably have to mention how to extract text and you will learn all of that in a little bit. So if you don't know code, don't worry. In a little bit, all of this will be very clear. But we have to install LangChain. If you go to docs, there will be a mention of this here. So it's a very extensive documentation and has a bunch of different use cases. So going to keep it simple for you. You need LangChain. Streamlit, like I said, Python is a backend language and it does not support front end like this, meaning you won't be able to see a UI. But because we are using Streamlit, which is an additional library that also gives powers to Python, like having a front end like this. So we will be using Streamlit for processing this or building the UI like this. And then OS and Time are libraries that come pre-built with Python. Now, why do we not have to install these two, and why do we have to install these two? The answer is simple, right? Because these libraries don't come pre-installed with Python because not everyone needs them. But these two libraries are what most people will likely need. So again, go ahead and install LangChain and Streamlit. And in order to install anything, you need to do pip install and then whatever you need to install. LangChain spelling is incorrect, so ensure that's correct before you install. And ensure L is small. Once you do this, this will pull everything we need for LangChain. One more important thing to do, we need to ensure that when we run the code, terminal also knows that we want to run from this environment and not our entire environment. So do Command Shift P or Control Shift P on Windows and click on Select Interpreter. And we want to select RAG environment. You can see it's recommended here, but by default, they've selected this one. So we don't want this. We want this one, right? So now it's selected. Every time we run the code, it will be able to take that environment now. So our first library is done. The next thing we want to install is pip install Streamlit, and it should also be done in a few seconds. The other two things we don't need to install. Now, if you were to import Streamlit as ST, you can see it's not showing error. But if I hadn't installed it, so let's say if I import something else, import python.env as python.env, you can see it's showing a yellow line, which means it's not installed or does not exist. So again, whatever you want to use in the project, you need to install it if it does not come predefined in the Python. So Streamlit is imported. Again, that's not something we want to do at the very start, but I just wanted to show you. First thing we will do is build session memories prompt and connect model. In very simple sense, every time I write a prompt, I want the model to use some data from the previous chat that we use for the user, right? So let's say this one, when I'm saying summarize this PDF, it's summarizing this. But when I say write a blog on this, I need the model to know that I'm referring to this. And hence, post that, it will be able to write a good blog. If I'm not using the previous knowledge, then it's not going to be doing a good job of summarizing this information, which is not something I'm looking at. So you need to do a couple of things. You need to ensure that a new prompt has some components of the history, the context, and the new question that the user is putting, right? So the history is that there is a PDF document attached. Context is that we are talking about OpenAI, and the new prompt is the write a blog on this, right? So let's define all of this now, but we also have to do the basics, right? So we want to first also ensure that whichever PDF user is uploading, it's kind of added in the project here because it then becomes easy to access, right? So if not os.path.exists PDF files, then make directory PDF file. I'm going to be using GitHub Copilot, so you can see the code recommendations after I type enter. It basically gives me recommendation with respect to what I'm going to be doing next, which is something I'll use because it makes the job easier. And you can see it's showing a yellow line on OS because it's not defined. So you can do import OS and then it goes away. You cannot import anything. It needs to be a part of the Python libraries. Next, we also need to do for vector DB. If I didn't mention what vector DB is, it's basically where your data will be stored, right? So whenever you break down the text, let's say 500-page PDF into smaller chunks, it needs to store that data somewhere. If you don't store it in vector DB, it's going to go inside of PDF again and again, and it's going to be inefficient. Or refer to that specific page of that PDF before it gives the output to us. We use vector DB for that. While a lot of systems that are available today are paid, we will be making a vector DB locally and for the sake of the example itself and not paying for anything else. So it's almost like a free local chatbot that we're building. Next, we need to build a prompt template, right? So a good prompt template would contain what? History of the previous chat, context to which the user is asking or what the user is asking, and also the user-based question, what new question the user has sent. So let's say if template not in st.session state. So basically what we are saying, every time you are opening Streamlit, it's maintaining some session. Session is meaning for that specific chat, we need all of these things in place. So when you're going to a chat session, when you're talking to a friend on WhatsApp, you're basically talking to them with some context, right? So that's a session. For that session, we are discussing this. So Streamlit enables you to maintain that session. And what we want to maintain in that session is the template of the prompt. So with the new prompt, we want to know what was previously talked about or the context of what the user is currently asking and so on. So if the prompt is not available in the session state, we want to create it. So if the prompt template is not in the session state, let's create it, right? So st.session_state.template is equal to, and then we will put the prompt. So I've already defined the prompt. I'm going to paste it here. So I went ahead and added this. You are a knowledgeable chatbot here to help with questions of the user. The tone should be professional and informative. Context is this, which we will also define in the future. History is this, which is something we'll also define. And then question of the user is this. So all of these things also we need to define now. Let's start by creating the prompt first, which we will send to the model as well. So now that the template is defined, we also need to share something with the model or the prompt template with the model. So let's go ahead and say if prompt not in st.session_state, then st.session_state.prompt, you can see it's similar. We were defining the template earlier. Now we're defining the prompt that we need to share with the model. Then we are saying build a prompt template, and prompt template would contain what? History, context, and the user question. That contains all of this. You can see there's a yellow line here because this is a LangChain import that we need to do, right? So let's go ahead and go to the top here, and let's say user prompt. We will import all the user-based prompts here. So once you add a hashtag, it becomes a comment, and this is not a usable code. This is for you to know what you're typing. So let's say from langchain.prompts, import prompt template, and now the error is gone. So basically we need to import the prompt template, and then now we need to define each of the things, the memory, the vector store, the LLM that we need to use, and so on. So let's create a memory. So memory not in session state, then st.session_state.memory. We need conversation buffer memory. Again, this is the memory that we are creating that will be maintained throughout the chatbot, and it will again be imported from langchain.memory, conversation buffer memory. Again, the memory key is history. So whatever is there in the memory is actually the history, and the input key is question. So every time a user is asking the question, it will refer to the history before it answers the question. Next, we need vector store. Like I said, we need a vector DB, and we'll be creating that locally. And we'll be using method called chroma for this, right? So if vector store is not in session state, then session state.vector store is equal to chroma persist directory vector DB, which is something that we created in here. And I'll also run this for you once. And then Ollama embeddings, because we're using the free Ollama library. This is very important. And then base URL is 11434. The reason is simple. If we go to Ollama page and you look at where it's running on 11434. So every time you see this active here, it's already running on this. So every time you put an API request on this, it's going to respond with the response. And we are using Ollama embeddings here. The model is Llama 2. Let's also import these two things. So for vector DB, we need chroma and Ollama embeddings. Okay, so now vector store is also defined. Now we need to also define which LLM that we are going to be using, right? So embeddings is different. Basically, like I said, embeddings is like a number probability with respect to how likely this is going to be the answer. So when I run this, I want to create embeddings for the Llama 2 model, but that does not mean this is the model that I want to use in order to generate response. Maybe I want to use GPT-4, but I want to store my data and create embeddings for this model. So in our scenario, we'll be using the same LLM, which is the Llama 2 LLM. But let's also define the LLM that we're using. So if LLM is not defined, then create a new LLM called Ollama on this base URL. Model is Llama 2. And then we have a bunch of different imports that we again need to do from LangChain. So you can see LLMs, LangChain community.llms, Ollama from steaming, std out. We're getting this one. And then from callback manager, this. Basically, this means that every time an input is sent to the user and the output is generated to the model, this communication between the model is done by this LangChain package here called Ollama. So LangChain has taken care of almost everything we need in order to build this RAG application. Then finally, chat history. And I think this is the last thing that we will have. We also need to maintain a chat history with respect to what was, the user input before and what is going to come after, right? Because that will be on our memory and context and so on. So let's say if this is not in the session state, then create a empty chat history. So every time a new session starts, an empty chat history will be initialized. We don't want to save anything from the previous chat history. Now, at this point, we've created all the main things we need. So we need the prompt that we'll send to the LLM, the template that we need to maintain for the prompt, the memory when to look at the history, then the vector store that we'll need to run the model, and then also the LLM that will actually generate the response. By the way, if you don't know how to run the code here, so if I'm going to, let me just comment all of this out. So how you comment this out is just select the text like you would do anywhere, and then command and /, it will comment or decomment your code, which means now we are only running these imports. These imports will do nothing because they are not used, but when you run this code, this should be able to automatically make PDF files and vector.db folders for you on the left here. You can see they created this folder because they don't exist. So basically we're checking if these folders exist. If they don't exist, then go ahead and create them. So now I'm going to do Control-Z to bring back my code. And let's start now working on the UI of the chatbot. So st.title, we'll call it chatbot to talk to PDFs. And then we also need to have the upload option for the user, like you see on the app here. We need to have the upload option for the user to upload the PDF. So let's say uploaded file is equal to st.file uploader. All of these again are Streamlit libraries. We are not getting anything new. All of these are automatically created, right? So if when we say st.file uploader, it knows that it needs to show a file uploader. And you can see the text to show on that is choose a PDF file, and the type we need to accept is PDF file. You can also do images, by the way, but so basically you can use Lava model. If you go to Mistral here, Lava can basically take images and process, should be Lava. Yeah, this model can basically take in images and give you output with respect to what is on those images, right? You can also accept images, and then if you learn how to build this, you can create your own chatbot that can give you answers with respect to what is in that image. Anyway, so let's continue building our chatbot. Now we need to maintain the chat history. So let's go ahead and create for message inside of chat history. Now chat history will have a messages in the array format, right? So for example, something like this. This is an array that we created here. You can see empty array, and it will have user with message, say A, B, C, D, and then comma, and then role, and then maybe something else like assistant with a message like how I can help you. And this is updated in real time, right? But we don't want to show it like this. Rather, we want to show it in a chat format like this, where there's the user question, there's the assistant answer, user question, assistant answer, and so on. So for this, we'll look inside of chat history, and then chat message role is what we'll look at. And then markdown wise, we'll show the message. And the reason is, if you look at here on the Llama 2 response, you can see the prompt is here. Basically, what we want to label this prompt as the user prompt, and the output we get from this as the assistant answer. So it will have, the message will have two things, the role and the message. If the role is user, show it differently. If the role is assistant, show it differently. Show content of both of them, which is in the message section in the prompt itself. Now the main upload and analyzing functionality is what we'll work on. So if uploaded file is not none, meaning if the user has uploaded something, then st.text, say file uploaded successfully, right? So first show the message that it has uploaded, the user has uploaded the file successfully. And then if not, os.path.exists PDF files, hold on. So what I'm saying is, if the file is not inside of this folder, uploaded file.name, if file is not inside of this folder, then show a message saying with st.status saving file, meaning we are still processing the file because it's not there. And now we will process the file as bytes because we need the text from it, right? So I'm going to quickly add the code here for that, and I'm going to be explaining it to you. So bytes data is equal to uploaded file.read. So we are reading the file and we are opening that file. And then once we read the file, we are closing the file. Post this, we need to show a loader, PyPDF loader. So we are going to now load the PDF file, which is inside of this Again, PyPDF is the library of LangChain. Luckily, like I said, it enables us to work across all the components of a RAG application. So let's import that as well. LangChain community document loaders, PyPDF loader. There is a spelling typo here. PyPDF loader, PDF files, uploaded file name. So we are loading this file. Once the file is loaded, we need to now get data from the file. So data is equal to loader.load. And then now once we know that, okay, these are all the text, this is all the text inside of this, we need to split it, right? Because you can't store all the text inside of one vector DB or one cell of vector DB, because then it's as good as just getting the data from PDF. We rather want to split it across different cells and then look into relevant cells when we want to fetch relevant data. So let's say text splitter is equal to, and we'll use LangChain library again, which is the recursive text splitter for PDF processing. This will break down the text of PDF into smaller chunks before we store it inside of our vector DB, which is empty right now. So we will use recursive text splitter, where the chunk size is 1500 tokens, chunk overlap is 200, and the length function is len. And then all splits is equal to text splitter, split documents into different data pointers. Then st.sessionState.vectorStore. Now we also need to store all of this data into our vector database. So let's store it in our vector database, chroma.from documents, and then documents is equal to all splits or embedding is equal to Ollama embeddings with model is equal to Llama O. So now we will store the document splits and Ollama splits in this session as well. And then we want to persist this, meaning we want to ensure that this stays throughout the session. I think mostly the document processing is now done. Post this, we basically want to build a retriever. Now we've built a way to store the data. Now you also want to retrieve it, right? So we will do session state.retriever is equal to session state.vectorStore as a retriever. So whatever you created inside of the vector DB here, you want to retrieve it from that. And this is the final bit of code we will write. If QA chain not in st.sessionState, QA chain is basically question and answer chain. Then we will create a QA chain, and I'm going to be adding a code here and then explaining it to you in a bit. So we are now fetching the QA state retrieval QA, and for this we'll again import the LangChain library that we need to use for this. So LangChain from chains retrieval QA, which will effectively help us get the content from in here. And you will see that we are getting from the chain type that we need to use the LLM that we set up earlier. See, this is this LLM we set up earlier. We're using the chain type as stuff, which is LangChain method to get content or text. And then retriever wise, we just set up a retriever in order to fetch it. And then verbose true, which will basically help us log everything that we see. So for example, when a machine is processing something or generating some sort of chat, then we will be able to use all of that. And then prompt is something we set up earlier, and the memory is also something that we set up earlier. So at this point, mostly what we need with respect to retrieval is done. Next, we need to set up like a chat based input from the user. So I'm going to be adding the code here where user input Streamlit chat is equal to you, then key will be user input. So for user input, we need to show something else and show it as a user message, while for an assistant input, we need to show it as the assistant message. You can see this is the user input and the below here is the assistant message. And we want to appear it as a chat window, and that will only happen once you append it. Right? We don't want to start a new chat every time a user is asking a question. So that's what we'll do, right? We'll separate chat as user and then show the text in the markdown, and separate assistant separately. And when the assistant is generating the text, we'll show the spinner. And after it's generated, we will show the code or whatever the user has generated or the assistant has generated. Now we'll also need to wait a few seconds after the text is generated before we show it to the user, right? So we will use something called time, which is again a Python library that will say, after the text is generated, wait for a few seconds before you show it to the user. And in the meantime, show a placeholder which is empty. After it's generated, show the actual text after 0.05 seconds. So let's import our final library, which is after OS, let's add import time. This will ensure that we only show the text after it's done processing. And I think at this point, mostly all you need to do to set up this is done. And this is, again, like I said, in scenarios where the PDF is uploaded by the user, right? So we need to also have an else statement where the PDF is not uploaded. So we just need to show a text saying else. So you can see if uploaded PDF is not none, meaning which is when it's not empty, then we do all of this processing. We analyze the PDF and so on. But if the PDF is not uploaded, then we need to show a message saying, please upload a PDF. So I think at this point, everything is done and your chatbot is set up. You can now go ahead and run this. I'm also going to be pasting the code here so that in the future, when you want access to it, you can use it. And now that's everything set up, we can go ahead and run the code. Ensure that your Ollama is running. And then once you verify everything, just type streamlit run app.py. Once you run this, you should be able to see, you'll be seeing an error because we need some libraries installed as well. So copy this command, pip install ChromaDB, and go to your terminal, do Control-C and type pip install ChromaDB. This will install a bunch of different things that we'll need to process our vector database. So you can see the installation process has started. Will take a few seconds. Like I said, VectorDB will not work if this is not involved. Basically, this allows us to create like a local environment to process this. So once you've done this, restart everything, close this, and then go back to your code and do streamlit run app.py. When you run this again, it's going to now work. Click on browse files and let's see if we have all the libraries we need for running PyPDF. So now when we upload this, it's going to show another error. So just copy this and go back to your code and type in pip install PyPDF2. Then once you run it now, this should hopefully not show any error. So let's upload the file now and you can see everything works. But it's not showing analyze here is because we've already copied the PDF before. So what you will need to do is just go into your folder and delete the PyPDF files and VectorDB files because we want to start from fresh. When you delete this and now stop this program, close this, go back to your code and run it now. And now everything should hopefully work. Select the file again and you can see it's now showing saving file or analyzing file. So it's now basically breaking the text down inside of the file into different small chunks and then we'll be storing it on our VectorDB. And you can see it's done now. You can start chatting with the model. So let's say you say something like summarize this. If you go back to your Visual Studio Code, you can see it's now coordinating with the Llama model. First, it's getting the text from VectorDB, then it gave it to the Llama model, and then now it's generating the output. You can see a new file is created inside of the VectorDB and the code is working. So you can see the output is now generated on the front end. So you can also add follow-up questions once this is done, and this will do the exact same thing. It will take the history from the previous chat. So so once you put the chat here and it's generated something, when you retry it, it's going to take history from the previous chat and generate the content again. So you can see we've built a RAG-based chatbot. We understood the concept. We understood the things we need to run this. We understood the libraries we need to run this and the methods we need to run this. And the code is also here. I'll add this in the description. But I hope I was able to help you build your own chatbot and help you understand what RAG is and why it's useful and why you are now, if you're at least using things like Perplexity, it's now being used by companies like these in order to solve the problems with LLMs. All right, guys, thank you so much.